Hi, hello, evening guys. So for my final video presentation, it isn't going to be as hands-on as most, and that's because my topic is celestial navigation. So me going outside and trying to demonstrate the skills that I picked up and learned over the course of the semester would be kind of challenging and difficult. So instead, what I did was create this small fun little worksheet that walks you guys through the process of everything, of what I learned at least. So yeah. Don't worry, it sounds like busy work, but it's not. It's actually super fun and super interesting too. So yeah, hopefully you guys can learn something. Alright, so in front of us right now is just a general map of the night sky. So let me just give you guys a quick run through of what we're hoping to achieve in this little worksheet. So there's essentially four things. We're looking to find the locations of Ursa Major, Ursa Minor, and Polaris. By knowing these three locations, we can then roughly predict the time by just using the night sky. So first things first, let's calculate Ursa, or look for Ursa Major. So if you look towards the bottom right of the map, this is its geometry. So it looks somewhat like a frying pan. So that's Ursa Major. And fun fact about it is it's also called the Big Dipper, and astronomers and travelers have used it for centuries because it's a celestial landmark. So this means that it's used to locate other stars and constellations. Okay, so up next is Ursa Minor. So it is towards the center left of the page, and it has a pretty similar geometry to Ursa Major. And the really cool thing about this is Polaris is actually located on the tail end of its geometry. So there it is right there. And Polaris is also known as the North Star, which serves as a beacon in the North sky. So this of course plays a critical role in navigation. Okay, so now that we have Ursa Major and Minor and Polaris, we can start to solve for time. So in order to do that, we need to, this caught me off guard when I was reading about it in the text. Or it was a really weird method, but we have to draw a vertical line from the far center right of Ursa Major to Polaris. So just a vertical line so that they connect like that. And this essentially will serve as an hour hand in a counterclockwise 24-hour clock, which you should see now. Okay, so I know this looks like a lot, but it's pretty simple once you think about it. So there again, the green hand serves as an hour hand, and this is a counterclockwise 24-hour clock. Okay, so just a disclaimer before we calculate time. This only works if the map is accurate. So if we went outside right now and took a picture of the sky, the map should look exactly like this. But for the sake of this video, we're just gonna run with it. Okay, so this is where it gets a bit more weird. So first calculation is we have to calculate the number of months since March 6th. So from today's date, we count back the number of months till March 6th, which was pretty weird when I heard about it, because like, why March 6th? But yeah, and that works out to be roughly 9 months. Okay, so we have that value. So next value we need is the intersection point between the green vertical line we drew to the circumference of the clock, or the circle. We need to get that number which it intersects, and it's 15. Okay, so from this we have everything. So now we take that 15 subtracted by our number of months multiplied by 2. So 15 minus 18 gives us -3. We gotta account for daylight saving hours because we're in that time, so we have to add 1. That gives us -2. And that's essentially it. So now we take 24, which is the number of hours in a day, subtracted by 2, and gives us our time, which is in military time. So 2200 hours is just 10 p.m. And there you have it. Yeah, there you have the time. Very funky, weird method to create time using the stars. So, yeah. Hopefully you guys learned something and enjoyed this demonstration. And yeah, I definitely had fun reading through it in the textbook. It was a lot of math and theory, but underlying themes and objectives was pretty fun. And I really do enjoy and love space, so this did intrigue me. Yeah, and that's about it. Yeah.